So we're going to continue talking about right triangles, and now we're going to talk about trigonometry and how it relates to right triangles. So when we have right triangles, there's my right angle. In trigonometry, we're going to be finding ratios that relate two of the three sides in the right triangle to a specific angle. So in this first triangle on the left, I have this angle labeled x. And now I can talk about these three sides as they relate to this specific angle x. So in a right triangle, when we're writing trigonometric ratios, we have an opposite side, we have an adjacent side, and then we have a hypotenuse. The hypotenuse is probably the one that you're familiar with. The opposite side is the side that's across from the angle we're talking about. So in this specific triangle, when I'm looking at angle x here, this is my opposite side. The hypotenuse is always across from the right angle, and that leaves one side left. We call this side the adjacent side. That means it's right next to that angle. So I'm going to do this one as well. Now we have a different angle we're looking at. So the angle opposite from x is the one across from it. This time it's this side. My hypotenuse is still across from the 90-degree angle, so it's in the same location. And the last side is my adjacent side. So it's going to be very important to be able to find the opposite, adjacent, and hypotenuse as it relates to an angle when we're going to write trig ratios. So I'm going to write the three trig ratios for this right triangle. And I'm going to go ahead and this is the first triangle we talked about. I'm going to label this side the opposite because it's across from the angle we're looking at. I'm going to label this side the hypotenuse. And this is the adjacent side. What a trig ratio is it's a ratio of two of the three sides that relate to a specific angle. In this case, this angle right here that we've labeled x degrees. So the sine ratio, which we abbreviate sin, these are functions, so I'm going to say sin of x. I can now write a ratio of a fraction of two of the sides. The sine is always the opposite side length divided by the hypotenuse. The cosine, which we abbreviate cos, the cosine of that angle is the adjacent side divided by the hypotenuse. And the tangent, which we abbreviate tan of that angle x, is the opposite side divided by the adjacent side. So if we know the lengths of the three sides of a triangle, so if we knew these three lengths, then we could write these three ratios and find the values for sine, cosine, and tangent. One sort of way that helps people remember which sides belong with which trig function is we can write so ka toa. If you remember so ka toa, it sometimes helps you remember that sine is opposite in hypotenuse, cosine is adjacent in hypotenuse, tangent is opposite and adjacent. So here we have an actual triangle where the sides are labeled, and we want to write the sine, cosine, and tangent for angle Z. So this angle right here, angle Z. So first, I always recommend finding the opposite side. That's right here. The hypotenuse is across from the right angle. And then the last side is the adjacent. So if we get those labeled, then all we need to do is look at the functions, which ones they belong with, and then plug the numbers in. So the sine of angle Z is the opposite, and I'll abbreviate, op over hypotenuse. The opposite side is 21. The hypotenuse is 35. And then, of course, we always simplify fractions. 21 and 35 are both divisible by 7, so this sine value is 3 over 5. The cosine of angle Z is the adjacent side over the hypotenuse. The adjacent side is 28. The hypotenuse is 35. We're going to simplify that. Both divisible by 7 again, this time 4 over 5. And last but not least, the tangent or tan of Z is the opposite side over the adjacent side. The opposite side is 21. The adjacent side is 28. They're both divisible by 7. That gives us a fraction of 3 over 4. So I want you to pause. So actually pause the video and write the sine, cosine, and tangent for angle X. So here you have the same triangle, but this time we're finding the sine, cosine, and tangent of angle X. So they're going to be different. My opposite side is over here. So now my opposite side is 28. My hypotenuse is still 35. And then my adjacent side is now 21. The sine of X is the opposite over the hypotenuse. That gives us 4 over 5. The cosine of X is the adjacent over the hypotenuse. That gives us 3 over 5. And the tangent is the opposite over the adjacent, and that gives us 4 over 3. So I want you to take this triangle, and I want you to write the sine, cosine, and tangent ratios for angle A. Do these, and you can check your answers in class.